Hello friends, in the last video we discussed the theory for calculating the average acceleration and instantaneous acceleration, and that was for two-dimensional motion. That is, if motion has two components of velocity Vx or Vy, then how we calculate these two terms, average acceleration and instantaneous acceleration. Now we will try to illustrate that theory using a problem in this video. And this problem we have already seen when we are doing calculation of average velocity and instantaneous velocity. So this is the same problem, but now we are going to calculate average acceleration and instantaneous acceleration. So problem says, a robotic vehicle or rover is exploring the surface of Mars. The stationary Mars lander is the origin of coordinates and the surrounding surface lies in XY plane. So we have a robotic vehicle and this vehicle is called Rover, and this is trying to explore the surface of Mars. This robotic vehicle is moving in a plane surface, that is, motion is in two dimensions, and the origin of coordinate lies with the lander. So on Mars we have lander, so this is a stationary Mars lander we are calling. So this is the origin of this system. So on the coordinate system, on the origin we have a stationary Mars lander, and this robot, the rover, is moving in a two-dimensional plane, particularly the XY plane. Furthermore, the question says the rover, which we represent as a point, has XY coordinates that vary with time, and the X coordinate is given by this expression and Y coordinate is given by this expression. So rover, we have to assume that rover is a point mass, and its X coordinate and Y coordinate is given by these two expressions, and these two expressions depends upon time. So for different time period you can calculate what is the value of X and what is the value of Y using these two expressions. Now the first part of the question, find the component of average acceleration for time interval of t is equals to 0 second to t is equals to 2 seconds. So we have to calculate components of average acceleration. This means we have to calculate X component of average acceleration and Y component of average acceleration. And this we have to consider for a time 0 to 2 seconds. So how will you do this problem? If you remember, the acceleration, for example, in the X direction, average acceleration in the X direction can be written as change in velocity in the X direction divided by the time interval. Similarly, acceleration in the Y direction, that is average acceleration in the Y direction, we can write delta Vy divided by delta t, where delta is the time interval and delta Vy is the change in the velocity. So I have to calculate what is the velocity at t is equals to 2 seconds and what is the velocity at t is equals to 0 second, and then I can calculate delta Vx, and then if I divide by delta t I can get the average acceleration in the X direction, that is X component of the average acceleration. Similarly, I can calculate Y component of average acceleration. So this means I have to first calculate velocity. So what is the X direction velocity? And this can easily be calculated because I know the position, X position of the rover. So if I differentiate this, I can get the velocity in the X direction. So X is given, so X is equals to 2 meter minus 0.25 meter per second square, and this is t square. Now if I differentiate, I can write dx by dt, and that is nothing but Vx, constant term differentiation 0, and this is 0.25 meter per second square, and differentiation of t square is 2t. So this will be minus 0.50 meter per second square times t. So this is the velocity in the x direction. Similarly, I can calculate velocity in the y direction, that is dy by dt, and this is equals to vy. So if you differentiate this, I will have 1 meter per second. So this is 1 meter per second, and differentiation of t is 1, and this is 0.025 meter per second cube, and differentiation of tq is 3t square. So if I rewrite this term, I will have 1 meter per second plus, and this becomes 0.075 meter per second cube, and this multiplied by the t square. So now I know the x component of the velocity and the y component of the velocity. So we can calculate what is the velocity at t is equals to 0. So let us calculate t is equals to 0. So what is the x component? This is, if I plug in this expression t is equals to 0, this becomes 0. What is vy? Vy, this term, that is this term will be 0. No, this term will not be 0. This term will be 0 because we have t square. So we will have vy is equals to 1 meter per second. Similarly, I can calculate velocity corresponding to t is equals to 2 seconds. So vx, what will be this value? So this term multiplied by 2. So 0.5 into 2, that is basically minus 1 meter per second. What is vy in this case? This term multiplied by 2, that is not 2, that is 2 raised to the power 2. So this will be, what will the vy? I can write 1 meter per second plus 0.075 meter per second cube, and this multiplied by 2 seconds raised to the power 2. So if you calculate this term, this will come 1.3 meter per second. So this is 1.3 meter per second. So now I know Vx and Vy corresponding to t is equals to 0 and t is equals to 2 seconds. I can calculate acceleration, that is average acceleration. So this is V2 minus V1 divided by T2 minus T1, that is delta V divided by delta T, and in the x direction. So what is the velocity in the x direction at 2 seconds? So this is minus 1 meter per second. So this is minus 1 meter per second. What is V1? So this value is 0. So you can see here, so this is 0 meter per second. What is the time difference? So we have 2 seconds minus 0 second. So this will be minus 0.5 meter per second square. So this is the acceleration in the x direction. Similarly, I can calculate average acceleration in the y direction. That is v2 in the y direction minus v1 in the y direction divided by t2 in the y direction minus t1 in the y direction. Basically, this is not y direction. Time has no direction. So this is simply t2 minus t1. So what is v2? V2 in this case we have, this is 1.3 meter per second. Minus what is v1? That is 1 meter per second. So this value is 1 meter per second. And this divided by 2 second minus 1, so 0 second. So this is how much? So if you calculate this, this will come 0.15 meter per second, a square. So this is the average acceleration in the x direction and in the y direction. So you see, to calculate the average acceleration, what we have to do? We have to first calculate the instantaneous velocity. That is velocity. Instantaneous velocity is simply called as velocity. So we have to calculate the velocity. Expression for the velocity. Once I have the expression for the velocity, I can calculate the velocity for any given point of time. And once I know this velocity for different times, I can simply calculate acceleration, that is the dv by dt. So dv I know, that is v2 minus v1, dt I know, that is t2 minus t1. So this is about calculation of average acceleration. Now next we will discuss how we can calculate instantaneous acceleration. So we have to calculate instantaneous acceleration at t is equals to 2 seconds. So what is instantaneous acceleration? So if you remember, instantaneous acceleration, for example, let us say if I say x component of instantaneous acceleration, so this is nothing but this is a limiting case when delta t tends to 0 and this delta v divided by delta t. And this can simply be written as dv by dt, and if I am calculating in the x direction, so I can write dvx. So dvx by dt, that will give me the instantaneous acceleration in the x direction. So the term vx we already calculated in the first part. If you remember, we calculated the vx. So what was the expression for vx? Vx is equals to, this was minus 0.05 meter per second square, and this multiplied by time. So that was the expression for Vx. Similarly, I remember the expression for Vy that we also calculated in the first part. So Vy was 1 meter per second plus 0.075 meter per second cube t square. So this was the expression for Vx, and this was the expression for Vy that we calculated in the first part of the problem. So now we will use these two expressions to calculate Ax and Ay. So let us calculate Ax. So I have to simply differentiate this term. So this will be minus 0.05 meter per second square, and differentiation of t is simply 1. So this will be the x component of acceleration. Now if I differentiate v by with respect to time, I will get a by. Now this is a constant term, differentiation of constant is 0, and then this will be 0.075 meter per second cube, and t square, the differentiation for t square is simply 2t. So now I can write v by, that is a by, is nothing but this will be 0. So this is 15 meter per second cube into time. So we calculated the two components of acceleration. So this is the first component and this is the second component of acceleration. Basically now I can write this acceleration in a combined acceleration vector. I can write because I know the component x component and y component. If you remember the acceleration vector, we can write simply axi cap plus a by j cap. So I can write using this expression. So a will be in this case simply ax is minus 0.05 meter per second square, and this is I cap, and plus this will be 0.15 meter per second cube t, and this is j cap. So this is y component and this is x component of acceleration. We have to calculate instantaneous acceleration at t is equals to 2 seconds. So let us plug t is equals to 2 seconds in this expression. So I will get this term will remain same, that is minus 0.05 meter per second square, and this is I cap, and this term will be, so if you put t equals to 2, this will become 0.30 meter per second square, because 1 second cancels out, and this will be j component of the acceleration, that is the y component of the acceleration. So this is the acceleration vector that we will have. Now acceleration vector, instantaneous acceleration vector, has two things. One is magnitude, another is direction. So basically we can find magnitude as well as direction both. So if you remember, magnitude of acceleration is simply ax square plus a by a square, and then you have to take the root, square root of this. So in this case, this value will be, this ax is nothing but minus 0.05 meter per second square. So square of this term plus 0.30 meter per second square, a square of this term, and then take the root of all. So this will come 0.58 meter per second square. So this is the magnitude of acceleration at t is equals to 2 seconds. Now we have to also find what is the direction of this acceleration, in which direction this acceleration is directed. If you remember, it was said in the beginning of the problem, so this is origin, that is the stationary lander position, and rover is somewhere, let's say here at t is equals to 2 seconds. It has two components of acceleration. One component is in the x direction, so this is my x-axis, this is my y-axis. So x component of acceleration is negative. This means x component of acceleration is in this direction. What is the magnitude? Magnitude is 0.05 meter per second square. And y component of acceleration is basically positive. So this is in this direction. And the magnitude is 0.30 meter per second square. So the resultant acceleration will be somewhere like this. So this is the x component of acceleration, this is the y component of acceleration, and this is your resultant acceleration. Now if you remember, in the previous classes we derived an expression how to calculate angle, this angle alpha, from the positive direction of x-axis. So we said we can calculate this angle, or sometimes this is also called beta. So you can so for velocity generally we reserve alpha term, and for acceleration we reserve beta term. So this angle is beta. So we can write tan beta is equals to a by e divided by ax. This is very simple. You can basically prove this. Now for this problem, a by e is equals to 0.30 meter per second square, and ax is negative 0.05 meter per second square. So if you calculate, you will get beta is equals to 31 degree. So in this case, if you take tan inverse of this term, so you will find beta is equals to basically minus 31 degree. Now what this minus sign says, this minus sign is saying this angle, if you count from this side, this angle is 31 degree. But if you want to count from this side, in that case you have to basically subtract from 180. So I can say this angle is how much? So this angle is basically 180 minus 31. So this is 149 degree. So from the positive direction of x-axis, the resultant acceleration vector is making an angle of 149 degree. And what is the magnitude of that acceleration? Magnitude is 0.58 meter per second square. So in this video we discussed about how to calculate average acceleration and instantaneous acceleration. So the takeaway message is, you have been given some x coordinate and y coordinate. It is easy to work in terms of component. First find out the vx and vy in terms of expressions. Once you have this expression for vx and vy, you can calculate these velocity at any given point of time and calculate those velocity, and then average acceleration is simple, that is change in the velocity divided by total change in the time, that is time interval. So that will give you the average velocity, average basically acceleration. Now instantaneous acceleration, you have to differentiate the velocity and then plug the time period for which you want to calculate the acceleration. Remember, the acceleration is a vector quantity. You have to calculate the magnitude of acceleration as well as you have to give answer for the angle that this is making with the positive direction of the x-axis. For this problem, positive direction of x-axis, this is making an angle of around 149 degree. I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.